In Grand Rapids, Michigan, high technology is changing the way cars are being made and the way men and women do their jobs.
In order to do the business we have to do today, we've got to go to this new technology. We've got to train our people better than we've ever trained them before and let those people come in here and do the job.
It's a competitive world in the automobile industry. In order to meet the foreign competition, innovative ideas and new technology must be integrated into the industry.
We know that if we don't do these new kinds of things in the very near future, we're not going to be in the business. So we've got to change our thinking. We've got to change the way we do things, or we won't stay in business. But we also feel that we're on top of that. We think we're going the right way, and in a matter of time here, we're going to meet that competition head on.
Computers are being used more and more in manufacturing. In Detroit, designers and engineers use computers to design automobiles. The process is called CAD, or computer-aided design. Once the design process has taken place, the information must be transmitted to the manufacturing plants. At that point, ideas, concepts, and plans must become the parts that form an automobile. Traditionally, tool and die makers physically shaped and molded the parts that, when fitted together, make the cars that you and I drive. Now, in Grand Rapids, tool and die makers use computers.
It's just like going back to school. You know, your basic background's a must, but the rest of it is just like going to college. I mean, you had to learn all over a completely different thing.
The process is called CAM, or computer-aided manufacturing. Now, those computer designs from Detroit are sent to the tool and die makers, who examine the data from Detroit and, using special computers, develop the information so that it can be transmitted to the machines that will make the parts.
I think management throughout General Motors and throughout the automobile business has found out that management alone cannot do this. Management needs the help of everybody in the plant, everybody in the tech centers. So without their help, it won't work.
The change began 2 years ago. Tool and die makers who might have lost their jobs to high technology were brought in from the assembly lines to operate high-tech equipment.
New technology being what it is, you actually have to participate. We thought you have to become involved in order to survive in the world market, to be competitive with the other people, and if we actually didn't, we only end up losing out.
12 people were selected to be a part of the program in its beginning. They were selected for their skills and their ability to teach others. While their jobs remained the same, where they worked and how they work did change. Not only have jobs been redefined, but communication within those jobs has changed. Workers from electronic data systems, the United Auto Workers, salaried workers, and management work in a cooperative effort.
I deal with at least 5 other departments that I never dealt with before. I deal with quality control direct. I never did before. I deal with maintenance. I solve a lot of little problems for various people that I never even knew their names in the past. You know, I just built dies. Now I relate even to the plant manager. We've opened up a whole new system of communications is what has happened.
Everyone who works in the CAM room works on a different aspect of manufacturing automobile parts. Most of the work going on in the CAM room is for Chevrolet Pontiac Canada Group's 1988 W model. Each person is a link in the manufacturing process chain.
You have to work together. As far as when they were out on the floor, I don't think they ever really came in contact with system engineers because they were just doing everything by hand.
It's a unique blend because, like I say, being from a manufacturing base and interfacing with these computer-oriented people, I find that we're learning together a lot of new things. I myself am learning a lot of things on the computer side, and in turn I get to share some of my experiences in the manufacturing world with them, so it's a very rewarding experience so far.
What makes this plant different is the people. The people that we have here are hard workers, they have a positive attitude, and this is what's making this whole thing work. We all work together. We don't try to say, well, no, that's your job, no, that's my job. We work together to try to make this operation a success.
The CAD, or computer-aided design, first enters the CAM room through Ed Harrell. He collects the data and checks it to see that each part is properly made. He also collects the data needed to make engineering changes. Deborah Sims and Ron Allen keep the software and hardware running. They use 3 terminals, the MVS, which displays jobs, the TSO, which edits files and monitors job output, and the JAZ, which handles system commands. Meanwhile, other tool and die workers work on other computers. They prepare and modify the data before the information is transferred to the machines, which will cut and grind the parts.
Basically what we do is take the design specs from Detroit, put these into our computer to create cutter paths, which we put on a floppy disk to give to the machinists so they can machine the raw castings.
Cutter paths are the routes that machines will follow to cut or form the automobile part. That information will be put onto computer disks that will program those machines.
You have to be very conscious of what the machine operator needs, what the bench people need. As I'm doing my job here, I'm really servicing other people more than I used to be on a floor. There's a lot of training going into this. I would say General Motors has put many dollars and many hours into me and the rest of the people in this immediate area in training. And there's much knowledge gained and there's much knowledge more to be gained. But I think I'm real proud to be a part of it all.
Each cam room worker goes through 2.5 months of basic training. At that time, they learn to use their knowledge and skills of tool and die making in combination with computers.
I know there's a lot of satisfaction in building something with your hands and watching it work. This has the same type of satisfaction because you're actually making it here on the screen. You can go out and watch it being machined.
3 different computers are used in the cam room. The DEX system is the forerunner of these computers. It is used for bringing in data, checking fixtures, making design changes, and profiling. The CAD Link system is used for wire burners, millwork, the NC block, or numerical content, and checking fixtures.
CGS we use for 3D contouring. We are one of the first plants to be using this application. We have done 8 panels now for the W program with very good results.
This is our last chance that we look at our cutter paths. We verify visually that they are correct, and at this time we customize the cutter path for the particular machine that it will be cut on. I think one of the things that I really enjoy about this is the accuracy involved. Always before it was a little bit of trial and error. You always felt you were right, but here you know you are. And it is proving out for us too. The dies we've cut have been right.
As one last method of backup, the cutter path data is checked on the machine. It is not metal, it is styrofoam.
What we have here is a piece of poly that we cut with NC data. We cut this on the NC machines. This is how we go in and verify our binder development before we actually cut steel out in the NC machines.
A design may go through many stages. It will be run through many of the 20 computers in the cam room. Instead of models being made in plaster, it will be models in styrofoam. Then it's cut on a wire burner, if it's small, or on one of the huge Toshiba cutters, or the Ingersoll, better known as the cooker, or cut by the precision of the laser. The work of the cam room has advanced automobile technology to a fine science, and instead of parts being eyed to see if they work properly, computer production will make a part accurately to within 1/1000th of an inch. What does this mean to you?
Well, I believe that the quality of the car you're going to buy is going to be far better than what you've had in the past. You should see better surfaces on the car. You should see mating surfaces match better. Door line openings along your trunk and your hood match very closely. This math data is very accurate. And when we machine it, we find that we're coming out very accurate on the tools and the dies that we are building. So you should see an improvement in quality of the automobile.
The unique men and women who work in the Grand Rapids cam room are not just cogs in the General Motors wheel.
We are the wheel. We're the hub almost of the corporation. That's what it's getting to. This is it. This is where it's all going to be. It starts here.